Hello everyone. In this video we will see how to perform multiplication in the case of matrices. So we will be focusing on two kind of multiplication. One, when a matrix is getting multiplied by a scalar, by a number, okay, or by a constant. And second will be the thing when we have to multiply two matrices. So let's consider the first one, matrix multiplication by a scalar. So scalar will be any number or a constant. So suppose if you have any matrix of dimension say 3 by 2 and means it's having 3 rows. So let me say the numbers are 1, 0, 2, 3, 5 and 2. Okay. If I want to find say 3a. So 3 is a scalar, okay, which is getting multiplied with the matrix. So again it will be a matrix which will be of same dimension. A is a 3 by 2 matrix, then 3a will be again a 3 by 2 matrix. So what will be the difference here? Different than this original matrix. It will be with the multiplication of this number. Here you have 3. So here you will be multiplying 3 with the original number 1. Okay, so it's like you keep the original elements at the same position and then multiply each one of them by this scalar. Okay, this scalar is getting multiplied with each one of them, each element. So this is how the scalar multiplication works. So the resulting matrix will be 3 times 1, 3, 3 times 2, 6, 15, 0, 9, 6. Okay, so this is how we do the scalar multiplication. What we did, we just multiplied the scalar with each and every element of the matrix. Now moving on to multiplication of two matrices. So similar to matrix addition and subtraction, when we multiply two matrices, we need to check some condition. Okay, so let's see what are those conditions. Multiplication of two matrices. So it's not like that we can multiply any two matrices. No, there is a condition. What is that? I will put it in a generalized form. If A is a matrix of order m by n, B is a matrix of order p by q, then you can multiply A and B, or you can simply write A star B is possible if the number of columns in first matrix is same as the number of rows in the second matrix. This is possible if n is equal to p. If n is not equal to p, then this multiplication is not possible. Okay, so remember here the position matters. If you are doing A multiply B, then the number of columns in the first matrix should match to the number of rows in the second matrix. If you change the position B multiply A, then it will be different. Okay, it will not be n and p, instead it will be q and m. Okay, so we have used this A and B, M and N and P to check if the multiplication is possible or not. So when we multiply two matrices, again we will get a matrix. So we should have the dimension of the matrix. So if this is possible, then if only if N is equal to P. Okay, and the dimension of the matrix A multiply B, sometimes we write A star B or sometimes we write AB, will be given by the remaining two numbers, which will be m by q. Okay, so for example, what we can say, if A is a matrix of order 2 by 3, B is a matrix of order 3 by 4, then in this case, as the number of columns in first matrix same as the number of rows in the second matrix, we say that AB is possible, okay, and its dimension will be 2 by 4. Okay. On the other hand, if you check BA, so B is a matrix of order 3 by 4. A is a matrix of order 2 by 3. Number of columns in first matrix is not matching the number of rows in the second matrix. So this is not possible. Okay. Why? As number of columns in matrix B is not same as, not equal to number of rows in matrix A. Okay, so these are the basics that you should know. Knowing the operation is good, but at least you should know when it is possible, when it is not possible. So once matrix multiplication is possible, let us see how do we do that. So I'll explain it with the help of example directly. So suppose if A is a 2 by 2 matrix, okay, 2 by 2 matrix, and B is any 2 by 3 matrix, 2 rows 3 columns. So say 1 0 minus 1 2 1 3. Okay, this is 2 by 3 matrix. So if I ask you to find A multiply B, we can simply write AB. Okay, so first of all you have to check if it is possible or not. A multiply B, A is first, so number of columns 2, number of rows 2. So yes, possible. So your solution start with AB is possible. Okay, and what will be the dimension of AB? It will be 2 by 3, the left out numbers. So how does this AB matrix look like? AB, it will be a 2 by 3 matrix, means it will be a matrix similar to matrix B. Okay, it is 2 by 3. So it means it is having some elements here in first row and the second row, right? If you remember from the previous video on basic of matrices, I say that what is the position of this? This is first row and first column, right? This is the position of this element. Remember, we are writing A11, first row, first column. Okay, similarly, what is the position of this? First row, column is 2. And same here, row is first, column is 3. Okay, so now when we are working on this, first row, we consider rows, we will consider from matrix A, and the columns we consider from the matrix B. Okay, so how it follows? First row of matrix A, we have to multiply with the first column of matrix B. So if we write, it will be first row is 2 multiply as multiplication, 2 multiply with 1 plus 3 multiply with 2. This solution gives you the element of AB, first row, first column element. Clear? Again, first row of matrix A and first column of matrix B. Similarly, here it says row 1, means again from matrix A. But from matrix B, we have second column. So, how do we write it? Row means 2, 3 is fixed. So, it will be 2 multiply. But here the column change. So, column now becomes 0, 1. 2 multiply 0 plus 3 multiply 1. Okay. Similarly, when we move to this element, it will be element here 2, 3 will be same. It will be using the third column. So it will be 2 multiply minus 1 plus 3 multiply 3. Clear? Now moving on to the second elements. So what it is? This is second row. So row 2, column 1. Means here the column remains same, the row change. Means this is column 1, 2 and 3, but row is 2. Okay, so here we will be working with second row. And we will do the same thing. First we select first column, second column and third column. Okay, so let's write it. So it will be 1 multiply 1, 0 multiply 2. Similarly, first row, second row and second column, 1 multiply 0, 0 multiply 1. And the last one, 1 multiply minus 1, 0 multiply 3. Okay, so be careful when you are performing these operations. First multiply and then add the result. Okay, means you need to solve this bracket first and then open and solve it. Otherwise you will do some calculation mistake. Okay, so be careful with this. So what this will give you? AB as 2 multiply 1 gives you 2 and 3 multiply 2 gives you 6. 2 plus 6, 8. Here 1 multiply 1 gives you 1 and 0 multiply 2 gives you 0. So it is 1. Similarly, we will find these elements. 3, 0. This will give you minus 2. This gives you minus 2. This gives you 9. Minus 2 plus 9 gives you 7. This gives you minus 1. So this is the matrix multiplication AB. Clear? Okay. So is it possible to find BA? BA. Is it possible? So B is a matrix of order 2 by 3. A is a matrix of order 2 by 2. So if we check, this 3 is not matching. So not possible. Okay. So what does it say? It gives you a property of matrix multiplication. What? AB is not equal to BA. Because sometimes AB is possible but BA is not possible. So it is not commutative. Okay. I hope it's clear.